Welcome back to Physics 30. This is part 2 of this second friction booklet. So number 4 says a 225 kilogram crate is pushed horizontally with a force of 710 newtons. If the coefficient of kinetic friction is 0.200, calculate the acceleration. Okay, so this will be a case in which, again, since there's acceleration, there must be a net force. So we must be applying a force that's bigger than the friction force. So if we take a look at what we have, we know the mass, we know the applied force, we know the kinetic friction coefficient. We're looking for A. So first of all, if we know the kinetic coefficient of kinetic friction, we should be able to figure out the friction force. So the only other piece of information we don't know is the normal force. It's a block that's horizontal. So this could be the free body diagram. The normal force and gravitational force are equal and opposite. We have an applied force that must be bigger than the kinetic force because it is accelerating. So there is a net force over to the right in my diagram. So to figure out Fn, I need to know Fg. So mass times gravity, 225 times negative 9.8, negative 2205. Therefore, the normal force must be positive 2205. So you can see here I rearranged this all for Fk, and it works out to be 441 newtons. That's the friction force. It makes sense that it's smaller than that because, again, I have a net force going to the right. So F net equals all the applied forces plus any friction forces. And of course, the friction force is a negative number, negative 441. And then I get 269 newtons as a final answer. Okay. Look at another one here. A sled of mass 50 kgs is pulled along a flat snow-covered surface. The static friction coefficient is 0.3 and the kinetic friction is 0.1. So again, to get it moving, I'm going to have to overcome some static friction, and to keep it moving, I'm going to have to overcome moving friction. Now I just realized here I forgot to answer the rest of the previous question. It did in fact ask for acceleration, so of course once I know the net force, F net equals ma, I can easily figure out what acceleration is. So my 269 divided by my mass of 225 kgs plus 1.20 meters per second squared. So sorry about that. So here's a diagram with the next one. So again, applied force is bigger than force of friction. What does the sled weigh? When we talk about weight, we're talking about force due to gravity. So 50 times negative 9.8, negative 490 newtons. Now, in order to get the sled moving, to overcome the static friction force, my applied force must be equal and opposite to it. So in terms of mathematically how that's related, Fa is equal to the negative of Fs. Because if this is a negative 10, let's say, if I take the negative of negative 10, it works out to be positive 10. So looking at the coefficient of friction, static friction, which is what I know, and of course Fn is the opposite of Fg, so the negative of negative 490 is positive 490. So you can see they're rearranging that, and I get my static friction force. So what this means, I get positive 147. I need to apply a force of 147 newtons forward to offset the friction force. If I apply any force larger than that, it will accelerate. And that's of course what you would have to do to get this object moving. Apply a force just slightly bigger than that friction force. So this is what my diagram would look like. In order to get it moving, I have to offset that 147 newtons. Next question, what do you need to keep the sled moving once it is moving? Now, constant velocity means that my applied force is going to have to be equal and opposite to my friction force. So with this, Of course, we're using coefficient of kinetic friction, which is a lot less because it's easier to keep a sled moving than it is to get it started to move, because remember the interlocking surfaces when it's at rest. Fn is still 490. So multiplying this out, the friction force is 49 newtons compared to 147 newtons on the previous case. So you can see it's a lot smaller. So once it's moving, if I apply 49 newtons, I offset the friction force and it keeps moving. Once moving, what total force must be applied to now accelerate the sled? 3 meters per second squared. So now it's like our previous questions. It's moving. We know what the friction is. What's the what force do I need to apply to accelerate it? So I know what A is. I need to find out what FA is, the applied force. I know what FK is. So the only thing that I need to know here is F net. What am I going to have? What is the overall force that needs to result in an acceleration of 3 meters per second squared forward? And of course, the other way I have to figure out F net is mass times acceleration. Earlier I was told the mass was 50 times 3, so 150 newtons. So back to here, 150 newtons is my net force. I know that I have 49 newtons of force working against me, negative. So I'd have to apply a larger force than 150 plus 149. Okay, the final calculating questions for objects just on a flat surface. It's a fairly big one, and we use a few equations from earlier on in the acceleration section. So you're driving a 2,500 kilogram car at a constant velocity of plus 14 meters per second along an icy but straight level road. As you approach an intersection, the traffic light turns red. You slam on the brakes. Your wheels lock because it's an older car. The tires begin skidding, and the cars slide to a halt in a displacement of 25 meters. What is the coefficient of kinetic friction? So the key thing with this is to write down all the pieces of information you know. We're asked to find coefficient of kinetic friction. We know the mass of the car. We know the car is initially going at plus 14. We're told that it comes to a stop eventually, so V final is 0. We know how far it goes, etc. Okay? So reasoning through this, we need to find the coefficient of kinetic friction. So our very last step is going to be this. Mu k is equal to Fk over Fn. So we're going to have to find the friction force. We're also going to have to find the normal force. Normal force is easy. It's just the opposite of gravity. But to figure out the coefficient of friction, the only other way I can do it is by looking at this. My F net equals Fa plus Fk equation. Now, since the only force that's being operated on here is the friction force of the car tires, my applied force is 0 because it's all friction. Rubber on ice is the entire thing. So as I mentioned here, there's no applied force since we're simply braking. So my net force is just going to be equal to my kinetic force. And I know how to figure out F net. The other way I have is mass times acceleration. I know mass. I don't know acceleration, but hey, I know initial velocity, final velocity, d. From earlier on, we have this equation. Okay, so you can see the rationale that's going to happen here. Use this to find A. Use this equation to find F net. F net and Fk will be equal. And then I'll be able to figure out the remaining pieces of information. So, first of all, if I'm looking at this, excuse me, I need to find Fg. Mass times gravity, 2,500 times negative 9.8, negative 24,500. So that's Fg. And of course, Fn has to be equal and opposite to that. So 24,500. Okay. Then backtracking here, equation 1 to 2 to 3. V final squared is equal to Vi squared plus 2AD. So as you can see here, initial velocity is 14. Final velocity is 0, so that's going to cancel out. 2 times 8 times 25, or I could take 2 times 25 to get 50. Subtract 196 from each side. So I get negative 196 is equal to 50 times A. So to undo multiply, I divide by 50. And acceleration is negative 3.92 meters per second squared. It makes sense that it's negative because you are slowing down to a stop, going from 14 down to 0. Okay, so far we're over here. We know what A is. To figure out F net, of course, mass times acceleration, negative 9,800 newtons. And I take my mass times that acceleration. And as I mentioned, that is what friction force is as well, because I'm not applying any force. My wheels are locked. I just have tires sliding on ice. So my friction is negative 9,800 newtons. So I know what friction is. I know what normal force is. Just use the size of the numbers themselves without negatives. My 9,800 newtons divided by normal force, 24,500, and I get 0.400. So fairly big question there, but simply read the question, write down your pieces of information. The unknown, try to figure out how you're going to do it, and then manipulate the equation in order to do so. Okay, that'll be it for the second part of the video, so you should be able to do the first quiz from this friction section. Okay, see you soon.